I want you to do an imagination exercise. Imagine that you are by the sea, enjoying the sun. You can hear the waves and the seagulls. Nice, isn't it? But now you feel a tremor. The sirens start to sound, the sea is rotating. What's going on? Well, these are some of the signs that a tsunami may be coming. Tsunamis are very long waves, usually produced by submarine earthquakes or landslides. They travel very fast, and when they reach the coast, they can be tens of meters high and very dangerous. So, what do? Go high. Look for tsunami evacuation signs, and if you don't see any, look for a tall building or hill. The sooner, the higher, and the farther you go from the sea, the better. But how high will be the waves? How large will be the flooding? How fast will the water be flowing? Well, looking for answers to these questions is what I do. And to do so, we generate tsunamis in our 36 meters wave room. We have a 5-meter wave maker and a 17-meter water reservoir in one side, the generation system, and a variable glass slope on the other side, the coast. We measure the flow velocities, how high are the waves, how fast they are traveling, and how far inland they propagate. So, problem solved, right? Well, it is not that simple. First, which tsunami do we generate? The 2004 in Indonesia or the 2011 in Japan? Tsunamis are like snowflakes. There aren't two alike. And moreover, the shape of the coastline and the seabed will have a large impact of the tsunami wave forms. And second, tsunamis are very long, tens to hundreds of kilometers length. To simulate these wavelengths in the laboratory, we need an enormous lab, or going to very small scales. We do not have such a huge lab, and going to these very small scales will reduce the precision of our measurements. So, to overcome these problems, we have defined a range of realistic tsunami wavefronts based on previous events and numerical models. We are focusing on the generation of these wavefronts because the results suggest that the flooding processes will be defined by the characteristics of these wavefronts. This data will later be used to study the relationship between the tsunami's strength and the flooding processes, and to validate numerical models that can be used to study with more detail the impact of tsunamis in large areas. With this information and some planning, we will be able to reduce the effects of tsunamis in the coast and to minimize the risk associated to these natural hazards. But just in case, next time you are by the sea, look for tsunami evacuation signs or tall buildings around hills. Could save your life.